Hello, my name is Fatima Azara binti Muhammad Zahid. My ID student is 2023389117.
Hi, my name is Badira Ashiki binti Zanari and my metric number is 2023516505.
Hi, my name is Harith Azrai bin Azahari. My matrix number is 2022772639.
My name Nur Afifa binti Abdul Hamid. My ID student 2024740989. This laboratory project determined key properties of pavement that will significantly influence road safety and performance. This test focused on understanding how pavement texture and drainage characteristics contribute to safe driving conditions and road durability. First, skid resistance test. Addressing the issue of reduced friction on wet or worn road surfaces, which can lead to accident. Second, sand patch test. Identifying areas with insufficient microtexture that may compromise tire grip and drainage. And lastly, surface drainage test. Evaluating poor water runoff on pavement, which increase the risk of hydroplaning and structure damage.
Safety precautions in the highway laboratory are important to prevent accidents and injuries during testing. Students must wear proper PPE such as lab coat, safety shoes, gloves, and safety goggles. Extra care must be taken when handling hot bitumen, aggregates, ovens, and testing machines. The working area should be kept clean and all instructions from the lecturer or laboratory technician must be followed at all times.
The objective of skid resistance is 1. To evaluate the frictional properties of road surface under various conditions. 2. To assess the ability of pavement to prevent skidding, especially in wet or high-speed scenarios.
Level the arm of the tester by make sure the bubble is at the center of circle. Next, adjust the level by make sure the slide rubber touch 3 points. Once the tester is ready, push the release button and record the data. Run the experiment at smooth surface at dry condition for 3 times. And then repeat the same procedure at rough surface for 3 times.
For the result and data, the skid resistance test was carried out on 2 different pavement surfaces, which are smooth surface and rough surface. Each surface was tested under 2 conditions, which are dry condition and wet conditions. 3 readings were taken for each condition and the average value was calculated. Based on the result, the smooth surface in dry condition recorded an average value of 111.33, while the smooth surfaces in wet condition recorded a lowest average value of 93. This shows that the skid resistance of the smooth surface decreased when water was present on the surface. For the rough surface, the average value in dry condition was 133 and 33, which is the highest reading in this test. Meanwhile, the average value for the rough surfaces in wet condition was 95. This also shows that the wet condition reduced the skid resistance value. Overall, the rough surface in dry condition gives the highest skid resistance, while the smooth surfaces in wet condition gives the lowest skid resistance.
Looking at the surface texture, our data clearly shows that the rough surface provides superior frictional properties compared to the smooth surface. In dry conditions, the rough surface achieved an average value of 133.33, while the smooth surface achieved 111.33. Even when wet, the rough surface maintained a slight edge. This is because the rougher pavement texture offers better aggregate contact and interlocking, which directly increases the friction coefficient. However, the most critical finding comes from introducing water. Moisture drastically reduces skid resistance across both surfaces. For the smooth surface, the value dropped from 111.33 to 93. More alarmingly, the rough surface saw its average plunge from 133.33 down to 95, a sharp decline of nearly 29%. This happens because water forms a lubricating film between the contact surfaces. This film reduces direct aggregate contact, drastically lowering the microtexture's effectiveness. To conclude, while a rough pavement surface significantly enhances friction when dry, wet conditions severely compromise its skid resistance. This directly fulfills our second objective, proving that managing water film thickness through proper pavement drainage and maintaining high microtexture is absolutely vital to preventing skidding and ensuring highway safety during wet scenarios.
The objective of the sand patch test is to measure the surface texture depth of a road pavement, and the second one to ensure the road surface has enough texture to provide good tire grip, especially during wet conditions.
The procedure of sand patches test. Part A. Test on a dry surface. First, a flat representative section of the asphalt pavement is selected. All dust, loose aggregate and debris are cleared away from the area using the hand brush. The area is ensured to be completely dry. Second, the measuring cylinder is filled with standardized sand exactly up to the 20 cm cube mark. The top surface is leveled off to ensure an accurate measurement. Third, the 20 cm cube of sand is gently poured into a small pile at the center of the clean test area. Then, the rubber face spreader disc is placed flat on top of the sand pile. Using light, uniform downward pressure, the disc is moved in an outgoing circular motion. The sand is spread until the surface voids are filled flush with the tops of the aggregate peaks, ensuring a well-defined circular patch is formed. The diameter of the sand circle is measured using the steel ruler. Measurements are taken in 3 or 4 different directions to account for any asymmetry, and the average value is calculated. Lastly, the sand is swept away and steps 1 to 5 are repeated at 2 other dry spots within the same section so that sufficient replicate data is obtained. Part B. Test on a wet surface. A new test area adjacent to the dry zone is selected. The asphalt surface is uniformly misted and dampened with a water sprayer to simulate post-rainfall conditions. Next, the measuring cylinder is refilled with a fresh batch of sand up to the 20 cm cube mark. Then, the sand is poured at the center of the wet zone. The sand is spread into a circle using the spreader disc in the same manner described in Part A. Lastly, the diameter of the wet sand patch is measured in 3 different directions and the values are recorded. The entire process is repeated for 2 other wet spots.
The result of the sand patch test used to measure the pavement microtexture. For the smooth surface, the sand patch diameter was 18 cm in dry condition and 14 cm in wet condition. A larger diameter indicates a smoother surface with lower microtexture. For the rough surface, the diameter decreased to 11.5 cm in dry condition and 10.5 cm in wet condition, indicating a much rougher surface with higher microtexture. Overall, the rough wet surface recorded the highest microtexture, while the smooth dry surface had the lowest microtexture. Higher microtexture improved water drainage and tire grip, which helped reduce the risk of skidding, especially during wet weather. In conclusion, the sand patch test shows that rougher pavement surface provide better skid resistance and improved road safety.
Discussion for sand patch is the pendulum test value PTV result shows that the rough surface provides better skid resistance than the smooth surface under both dry and wet conditions. The rough surface recorded PTV values of dry, which is 75.2, and wet is 65, which meet or exceed the minimum requirement for category A roads. PTV is equal to 65. This indicates excellent skid resistance and a lower risk of vehicle skidding. In comparison, the smooth surface achieve PTV value of dry, which is 60, and wet is 48. The dry conditions satisfy the category B requirement PTV equals to 55, while the wet condition only meets and the minimum requirement for category C roads PTV equals to 45. The lower PTV under wet condition indicates a reduction in tire pavement friction due to presence of water. Overall, the results demonstrate the rough pavement surface provide higher skid resistance than the smooth surface.
The objectives of this tests are to evaluate the surface drainage capability of a pavement surface caused by measuring the time taken for a known volume of water to escape through the surface texture voids using an outlet flow meter. Second one is to identify the hydroplaning potential of a selected pavement section under wet operating conditions. And the last one is to correlate surface drainage performance with pavement macrotexture depth and its overall impact on vehicle skid resistance.
Pour 300 ml of water into the outflow meter. Open the valve and start the stopwatch to record the time. Run the test for 3 times to get the average data. Repeat the same procedure for smooth surface.
For this result, the surface drainage test was carried out on 2 types of pavement surfaces, which are smooth surface and rough surface. Both surfaces were tested under dry conditions using the same volume of water, which is 300 ml. Based on the result, the smooth surface recorded a time taken of 7.54 seconds for the water to drain. The drainage rate for the smooth surface is 39.79 ml per second and it is classified as moderate drainage. Meanwhile, the rough surfaces recorded a shorter time taken, which is 5.94 seconds. The drainage rate for the rough surface is 50.51 ml per second and it is classified as good drainage.
The surface drainage test was conducted to evaluate the effect of surface texture on drainage performance using the same water volume 300 ml under dry condition. The result showed that the rough surface exhibit better drainage performance than the smooth surface, requiring only 5.94 seconds to drain the water compared to 7.54 seconds for the smooth surface. Consequently, the rough surface achieved a higher drainage rate of 50.51 ml per second, while the smooth surface recorded 39.79 ml per second, indicating that the rough surface drained approximately 27% faster. This improvement attributed to the greater surface texture, which provide better flow path for the water, reduce water retention on the surface. In contrast, the smoother surface allows water to remain on the pavement for a longer period due to the lack of surface irregularities. Therefore, the result demonstrates that increasing surface roughness enhances drainage efficiency, which can contribute to improved skid resistance and road safety by reducing water accumulation on the pavement surface.
In conclusion, these 3 tests prove that wet weather pavement safety relies on a unified system. The sand patch and drainage tests evaluate how quickly bulk water is cleared from the surface through the pavement's microtexture. Once that water is removed, the skid resistance test ensures the aggregate's microtexture can directly grip the tire, effectively preventing hydroplaning. Thank you.